Good morning to all. Subject is Basic Electrical Engineering for ECNCS branch. In last video, I discussed about analysis of series parallel electric circuits and characteristics of series parallel electric circuits. That is, RS is equal to R1 plus R2 plus R3 for series electric circuits, and 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 for parallel electric circuits. Then today's topic is current in a parallel branch. If two resistances are connected in parallel, what is the equation of current I1 and what is the equation of current I2? Okay, if we are consider two resistors R1 and R2 are connected in parallel, then what is the equation of current I1? Then what is the equation of I2? Here I is the total current, V is the total voltage. R1 and R2 are two resistances. Here input node and this is the output node. This is one parallel electric circuits. If two resistances are connected in parallel, 1 by Rp is equal to 1 by R1 plus 1 by R2. Okay. Now what is the equation of I1 and I2? You can calculate. The equations are coming here. Then you can solve. Then apply Ohm's law. For whole circuit. Okay, that is IT is equal to VT by RT. That is IT is equal to VT by RT. Here IT is the total current, VT is the total voltage, RT is the total resistance for whole circuit. Now apply Ohm's law for R1 and R2 circuit. Okay, therefore I1 is equal to V by R1. Then R2 circuit I2 is equal to V by R2. In parallel circuit, the voltage, the potential drop across in R1 and R2 is same. In parallel circuit, the voltage is same for all resistances. That is V. R1 is potential drop is V. R2 is potential drop is also V. Okay. Here the voltage will be same for R1 and R2 circuits. Therefore, I1 is equal to V by R1. I2 is equal to V by R2. Okay. Now therefore V is equal to I1 into R1. Here V is equal to I2 into R2. Therefore now write for calculate total resistance of parallel electric circuit. 1 by RT is equal to 1 by R1 plus 1 by R2. Therefore, RT is equal to R1 into R2 divided by R1 plus R2. Leave it. Now, your main intention is for finding the value of I1 and I2. Finding the value of I1 and I2. Therefore, V is equal to I1 into R1. That is nothing but V total. V total is called as VT is equal to IT into RT. Using this voltage equation, put here V is equal to IT into RT is equal to I1 into R1. RT is total resistance for this circuit. Using voltage equation for first R1 equation, V is equal to I1 into R1. But V is nothing but total voltage is equation using VT is equal to I2 into RT. You can put here VT is equal to IT into RT as it is I1 into R1. Therefore, I1 is equal to IT into RT divided by R1. For calculating I1 equation, IT as it is total current for the circuits. RT means if two resistances are connected in parallel, R1 into R2 divided by R1 plus R2. This R1 as it is. This R1 will get cancelled. The equation for first branch resistors is I1 is equal to total current into opposite resistance divided by sum of the resistance. This is your first current equation. As same way you calculate for second V2 means V is equal to I2 into R2. Then it is V2 means VT. VT is IT into RT. Therefore, I2 into R2. Okay, therefore, for calculating second branch current, I2 is equal to IT into RT divided by R2. Now, you can put the value of RT here, IT. RT means the total resistance for this circuit. RT is R1 into R2 divided by R1 plus R2. Now, this R2 as it is. For current second equation is I2 is equal, this R2 will get cancelled. IT into R1 divided by R1 plus R2. This is your second current equation. The total second branch I2 is equal to IT into opposite resistance, that is R1 divided by R1, sum of all resistance R1 plus R2. If two resistances are connected, the first current I1 is equal to IT into R2 divided by R1 plus R2. The second current equation I2 is equal to total current into opposite resistance divided by sum of the resistance. This is I1 equation and this is I2 equation. This is if two parallel branch connections is there for finding I1 and I2 easily. Now the next topic is power equations. In last video I give the equation for power as V is equal to P is equal to V into I. Okay, by using Ohm's law you are getting another power equations. P is equal to, using Ohm's law, I is equal to V by R. Now power is equal to V into I. Now I can be replaced as you write V by R. V as it is, I is equal to V by R. Therefore power equation becomes V square by. This is another power equation for electric circuits. Therefore then I is equal to, using Ohm's law only, I is equal to V by R. Therefore V is equal to I into R. Now you can put the value of V in power equations. Therefore modified second power equation as V, as you can replace write the equation for V as I into R. This I as it is, then power is equal to I square into R. This is your third power equations. Measured in watts, measured in minutes, measured. Power is equal to V into I. Power is equal to V square by R. Power is equal to I square into R. Okay, all these equations you can use for solving some problems. Okay, then next topic is the problems on parallel and series electric circuits. Then using power equations you can solve some problems. Then first problem is two resistances 20 ohm and 40 ohm are connected in parallel. Two resistances are there here. The values are 20 ohm and 40 ohm are connected in parallel. A resistance of 10 ohm is connected in series with the combination. A two resistances of 20 ohm and 40 ohm are connected in parallel. A resistance of 10 ohm is connected in series with the combination. A voltage of 200 volts is applied across the circuit. The current in each resistance. Find current in each resistance and find also voltage across 10 ohm. Find also the power consumed in all resistances. It is the type of electric circuit is series parallel electric circuits. 20 ohm and 40 ohm are connected in parallel. In this combination is connected in 10 ohm resistors with a voltage source of 200 volts. The total voltage is 200 volts. Find the current in each resistance, means there are three resistances are there, 20 ohm, 40 ohm and 10 ohm. Find the currents in 20 ohm, 40 ohm and 10 ohm. Find also power consumed in all resistors, 20 ohm, 40 ohm and 10 ohm. You can find calculate power consumed, that is P is 20 power consumed 20 ohm, 40 ohm and 10 ohm. Then find also voltage drop across in 10 ohm. How much the voltage will be drop across in 10 ohm. Okay, first you can draw the circuit diagram. 20 ohm and 40 ohm are connected in parallel. If here 20 ohm and 40 ohm are connected in parallel, here 20 ohm and 40 ohm. Then this combination is connected in series with 10 ohm across a voltage source of 200 volts. Call as I, I1, I2. Okay, this is I. Now given data, write down given data first. 20 ohm referred as R1, 40 ohm is referred as R2, then 10 ohm is referred as R3. Vt is the total voltage. Okay. Calculate total current in resistance, that is I1 is question mark, I2 is question mark, then I is question mark. Now find also voltage drop across in 10 ohm is question mark. Then find power consumed in 20 ohm is question mark, power consumed in 10 ohm is question mark, power consumed is 40 ohm is question mark. These are asking questions. Now first to find total voltage is known, total resistance you find for getting total current. Okay, therefore total resistance for electric circuits, it is parallel, it is yes, totally it is series parallel electric circuits. Rp is equal to R1 into R2 divided by R1 plus R2. R parallel, if two resistances are connected in parallel, R1 into R2 divided by R1 plus R2. R1 value is 20, R2 value is 40. 20 plus 40, then you will calculate the, it is getting the values is 13.33 ohm. Therefore R3 is 10 ohm. Then total resistance for it is series electric circuits, RT is equal to Rp plus 10. Rp value is 13.33 ohm, then plus 10 means total resistance for series electric circuit is 23.33 ohm. Okay. Next, you find voltage drop across in 10 ohm. Then find I1 and I2 using branch current formula. Using branch current formula, that is I1 is equal to total current into opposite resistance divided by sum of the resistors. Using branch current formula, find I1 is equal to IT into R2. Therefore total current is given or not, using I1. Therefore using Ohm's law, IT is equal to Vt by RT. Okay, Vt is 200, RT is 23.33. Okay, therefore total current IT is equal to 8. For calculate, you are getting 8.5 ampere. Now using branch current formula, find the R1 branch currents and R2 branch current. I1 total current is 8.5, R2 is 40 ohm, R1 plus R2 20 plus 40. Then find the first branch current is 5.7 ampere. Using calculator, then find I1 values. Okay, and same way find I2. I2 is equal to total current into opposite resistance divided by sum of the resistance. That is I2 is equal to total current is 8.57 into opposite resistance is 20 divided by sum of the resistance 20 plus 40. Okay, therefore I2 branch current is calculate 8.6 ampere. Okay, then next voltage drop across in 10 ohm, that is I into R using Ohm's law. Then here you can using this total current, here 5.71, here 2.86, total current is 8.5. Then I into R, you are getting potential drop across in 10 ohm. Therefore here 8.57 into 10 means 85.7 volts voltage drop across in 10 ohm. Next, power consumed in all resistances. Power consumed in first 20 ohm, that is I1 square into R1. I1 means your 5.7, you put the value as 5.7 square, R1 is 20, calculate, then you are getting like 652.0 watts. Then power consumed in 40 ohm as I2 square into R2. I2 value is 2.86 square, then R2 is 1. I2 here calculated using branch current 2.86, then R2 is 40. Then you are getting, then calculate using calculator, then you are getting value as 327.18 watts. Then power consumed in 10 ohm. Here I square into R3. I means here 8.57 square, R is 10. Then calculate, then using, then we're getting the value as 734.45 watts. Okay, in this problem they will ask the question like this: find the current in each resistors, means I1, I2, then I, that is I1 is 5.7, I2 is 2.86, then I is 8.57. Using Ohm's law and analysis of series parallel electric circuit, then using all these one, finding I1, I2, then I, then potential drop across in 10 ohm is I into R. You are getting these values. Okay, now power consumed in all resistors. Okay, this is your first problem. Then second problem, a resistance R is connected in series with a parallel circuit consisting of 20 and 40 watt. The total power dissipated in the circuit is 1000 watts and applied the voltage is 250 watts. 250 volts. Calculate R. If here resistance R is connected in series with the parallel circuit, this is R. Then here parallel circuit 20 and 48 ohm, 20 ohm and 48 ohm. Okay, R is connected in series with the circuit combination across the voltage source is 250 volts. Then total power dissipated PT is equal to 1000 watts. Calculate R. Okay, now find, here it is first to find total resistance for this circuit. If two resistances are connected in parallel, 20 into 48 divided by 20 plus 48. Okay, R1 into R2 divided by R1 plus R2. Now you using power equations, PT is equal to V square by RT. Using power equations, VT total voltage square total resistance, then total resistance for this circuit is unknown. VT square divided by power. VT means 250 square divided by power is 1000 watts. Okay, it is nothing but total resistance for electric circuits. Now you can, using series and parallel equations, total resistance R is equal to R1 plus R1 into R2 divided by R1 plus R2. Okay, this is total resistance is 250 square divided by 1000 R as it is, plus R1 into R2 20 into 48 divided by 20 plus 48. Then calculate, you are getting R equations. This is your second problem. Okay, this is your second problem. Using analysis of series and parallel equations, then Ohm's law, then power equations, you calculate unknown resistors. Okay, thank you.